This section is radical expressions, and we're going to start with simplifying. So we're going to first start by looking at the square root. So basically think what squared will give us 49. Our answer is 7. On this next one, we have negative square root of 25. So negative square root of 25 is 5. So we get negative 5. On this one, it's the same thing as the square root of 81 over square root of 64. Square root of 81 is 9. Square root of 64 is 8. This last one, what squared will give us negative 9? Well, nothing times itself will give us a negative number, because a negative times a negative would give us a positive 9, and a positive times a positive would give us a 9. So this one is not real. And it's all because of that negative. So now, when we have the square root of a squared, we'll think about what squared will give us a squared. Well, it's just a, but it's got to be the absolute value, because when we take the square root, we talk about the principal square root, which will always be a positive number. So we need the absolute value of the variable. This next one, the square root of 25b squared, well, the square root of 25 is 5. But then with the square root of b squared is the absolute value of b. With these next two, same thing. The squared and the square roots you can think of as canceling each other out. So the square root of this quantity squared is just the quantity. But it's got to be in the square roots, because remember, it's the positive of this. And this last one, square root of 16 is 4. And then what squared gives us a to the 4th? Well, that would be a squared. One thing to note, it doesn't need the parentheses, or sorry, absolute value. And that's because a squared is always positive. And that's because anytime you square a number, the result will be positive. Now with these, notice that little 3, that just means cube root. So what is the cubed root of 8, or what cubed will give us 8? Well, 2 when we cube it gives us 8. Over here, this is the same thing as the cubed root of 1 over the cubed root of 27. So what when we cube it gives us 1? Well, that's 1. And what when we cube it gives us 27? Well, that's 3. Same thing here. What cubed will give us 125? Well, that's 5. What cubed will give us a cubed? That's just a. Notice we don't need the absolute values anymore, because this time the sign actually matters. So if we have, for example, negative 2 cubed, that's negative 2 times negative 2 times negative 2, which is negative 8. But if we have 2 cubed, we'll have 2 times 2 times 2, which is a positive 8. So now, if it's a negative when it's getting cubed, we end up with a negative. So the negatives aren't going to disappear by multiplying out. Now this last one, what cubed gives us negative 8? Well, negative 2 when we cube it will give us 8. And that comes back to here. So same idea here, except now we're doing the 4th root. We'll think about what to the 4th power is 1. That's just 1. And this is saying what to the 4th power equals 81? Well, that'll be 3. Now in this one, notice this is the same thing as 10 to the 5th times a to the 5th times a to the 5th times a to the 5th. And so, oops. And so 10 to the fifth root, remember those are like canceling their inverse operations. And then we have the fifth root of a to the fifth would just be a. Fifth root of a to the fifth is a. Same thing. So we're left with a cubed. Some helpful rules to think about. If you're taking the sum root of a number to that same power, and that power and root are odd, then it's just, they're going to cancel each other out. They're inverse operations. You're just left with a. However, if we have the same thing and it's even, remember we have to use the absolute values.